Hello, ladies and gentlemen. Welcome to chapter number 2B, more factoring. Okay, let's take a look at what we have here. So we're going to be talking about factoring some more today. We've been doing some factoring, and you've been doing factoring since grade 9, to be honest with you. Here's a question. Factoring, well, it's not a question, it's a statement. Factoring is working backwards to find the multiplication question that would generate the given expression. So this question says factor. So this means I want to go backwards and find out the multiplication question that would create this. So expand is different than factoring. In fact, expanding and factoring are what we call opposite operations. They undo each other. So I'm going to make this a little bit bigger. And we're going to look at expanding. And expanding means the distributive property. So we expand that to give us 6x plus 14. So we took the 2 and we multiplied it by the 3, and we took the 2 and we multiplied it by the 7. If there were like terms, then we would collect like terms. There aren't, so we're done. However, factoring. Factoring, we're going to be looking for what is common multiple in each of those. So a 6 can be divided by 2 and a 14 can be divided by 2, which means I can common factor out a 2, leaving me with 3x plus 7. I can go backwards and expand it because they're opposite operations. 2 times 3x is 6x, times 2 is 14. And so if I go backwards, it's called expanding. And if I go forward, it's called factoring. Okay. What's the other thing I can tell you about that? Well, you should be okay with this, but really what's happening here is if you look at that 6x, what you've got is you've got a 2 times a 3 times an x, and the 14 you've got a 2 times a 7. So what I'm really doing is I'm looking at that 2 that's in the first term, I'm looking at that 2 that's in the second term, I'm putting it out front to multiply in, so then I'm just left with the 3x and the 7. So that's how that works. Okay, so common factoring, and I've got 2 examples here, A and B. So the first one is a trinomial. I'm not going to factor it like a trinomial because this question's asking for common factoring. And I notice that I've got a 10x squared, a 15x, and a 25. All of them have a multiple of 5 in them. 10 is 2 times 5, 15 is 3 times 5, and 25 is 5 times 5. So if I take out that 5, it's going to leave me with 2x squared plus 3x plus 5. Meaning that I did 10x squared divided by 5, which is 2x squared, 15x divided by 5, which is 3x, and 25 divided by 5, which is 5. That is factored. Over here we have 4 terms. Let's take a look at them. What's common in all 4? Well, I think I could take a 4 out of this, a 4 out of that, a 4 out of this, and a 4 out of that. Meaning 16 divided by 4 is 4a. 12 divided by 4 is 3b. 8 divided by 4 is 2c. And 4 divided by 4 is 1. Don't forget that 1. That's a placeholder. You need this. If you don't have this, it is wrong. And when you go to expand it, you'll see why. I need 16a. 12b, negative 8c, and without that 1, I ain't getting that 4. Okay, so a common factor can be a number can be a number. Woohoo! Let's look at the next examples. So I've got 3 terms. What's common in all 3? 2, 3, and 5? Nope, they got nothing in common. They're all prime numbers. X, X, and X, they all have an X. Y, Y, they don't all have a Y. Z, they don't all have a Z. But they all had an X, do you remember? So it's 2Y plus 3Z plus 5YZ. Now, yes, I know my Z's look weird. Get used to it, that's what they are. And there's my X on the outside. Okay, let's see what's next. Well, x to the 4 means x times x times x times x. There's 4 x's here. And x to the 3 means x times x times x. There's 3 x's here. And x squared means x times x. So there's 2 x's here. So how many x's do all of them have? Well, this one has 2, this one has 3, this one has 4. So the most I can take out of all 3 is 2. leaving me with the 2 left over from the 4 when I take 2 away, leaving me with the 1 left over when I take 2 away from the 3, and leaving me with just the 4 because I took both x's away here. Now if you want to see what's happening here, this is the same as 5, x, 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 plus 7, x, 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 minus 4, x, x. And I think you can readily see now that this has 2 x's, this has 2 x's, and this is 2 x's. And if I take those 2 x's and put them out front for x squared, it leaves me with 5x squared, 7x, and simply negative 4. Number 2c, 20, 30, 50. Well, they can all be divided by 10. X cubed, x squared, x. I can take an x out of all of them, so it's going to leave me with 2x squared plus 3x minus 5. Now, we stop there. That's it for common factoring. I take the 10x. This is a trinomial. We're going to learn later today ways of factoring a trinomial that looks like this, but for right now, we're just common factoring, so we stop. This one here, we have 2 terms. What's common? Well, it looks like I can take a 3 out of 9 and a 3 out of 12, so a 3. X squared, x4, so x squared comes out of both. Y cubed and y, so 1y can come out of both, so it's going to be 3y squared minus 4x squared. Now that one is a little weird. I'm going to check it. Hey, don't forget your equal signs. That'll cost you a mark if you do. So 3 times 3 is 9, x squared, y times y squared is x squared y cubed, because it's y to the 1 and y squared is y cubed. And 3 times 4 is negative 12. And it works. So yay, that was good. So what do I put here? A common factor can be a number and or a variable. And it could be more than one variable because we took out 2 variables here. So it can be a number and or a variable. In this one, it was just a variable and no number. Well, if you really wanted to, you could say it's a 1 in front of there. Or in this one, it's a number other than 1. It's 10 and a variable. And this one, it's a number and more than one variable. So that's exciting. Number 3. Ooh, this is cool. Look, 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 look. 2x bracket x plus 3 plus 9 bracket x plus 3. You know what's the same? The bracket x plus 3. Look at it. They both have one. That's seriously cool. Let's factor it out. So we factor out an x plus 3. It'll leave you with a 2x plus 9. Check it. X plus 3 times 2x is 2x times x plus 3. X plus 3 times 9 is 9x plus 3. That is so cool. So we are common factoring out a binomial. Over here, so I have a 15x, a 17y. They got nothing in common. But the binomials are the same. Totally cool. So we're going to common factor out the binomial. And life is grand. On to C. 8a, 5a plus 9. That's a binomial. And looky, looky, there's another binomial. But if I divide out this binomial, I'm going to need a placeholder of 1, just like I did before. So look what's going to happen. 5a plus 9. By the way, you got to put that in brackets. If you don't put that in brackets, it's different. Without the brackets, that says x plus 3 times what's in the brackets. It's both of them times what's inside the brackets. So you need those brackets. And this is going to be 8a minus 1. And you need that 1. Don't forget about that 1. You need this. Because if you don't have it, when you expand it, it's going to be 8a times the brackets. And you're not going to have this other negative 1, 5a plus 9. So make sure you put that in. You need this. Okay. Okay, next one. Well, there's your binomials. They're going to be the same. I'm going to common factor them out. But there's more that can come out. Look, 22 and 33, they both have a multiple of 11. Oh, this is so cool. Now, you could do it all in one shot, or we can take our time. Let's take our time and do this. I think everyone can follow that. And then notice that 22 and 33 have a multiple of 11. And that looks a little weird. It's not wrong. Won't take a mark off. But it looks better if we write it like this. Now, that being said, you could have done this in one step. You notice 22 and 33 have a multiple of 11. You notice that the x and the x minus 1, and that'll leave you with 2x plus 3. That's kind of hard to do all in your head. I would be careful with doing that. I would do the steps, but it's perfectly doable. And remember, that's a 2x plus 3. Okay, I'm going to stop there, and then we'll do the backside of this sheet.